Wait. சொல்லுங்க. என்ன? Katanya JB Chile போறீங்க மனா நான் JB ல போறேன் சாக்லேட்ஸ் கீழெல்லாம் பீட்டியானா ஐயா என்னமா வேணும் டிக்கெட் குட்டில குடிச்சு வைக்கிறேன் அதுல கலர் பண்ணி ஸ்லிப்ப எடுத்து வைக்க சொல்லிட்டு திரும்பினா எல்லாம் கலர் பண்ணி கீழே இனா கிட்ட டேடா கிட்ட Sarah, now you are going to sleep or not? Sleep. Okay, Sarah. Don't do that. You keep all the chalks. Put all the chalks inside. Then I show you something.
Assalamualaikum everyone. Can you all hear me, children? Can you all hear me? Leave a message to the co-host. Can you all hear me? Yeah, give me a minute. So from now onwards, if you have any doubts while studying or anything that you wanted to be clarified, leave a message to the co-host, right? Not to the host. I have joined through 2 devices, so make sure to leave a message to the co-host, right?
It cannot message.
So yes. So before we go into the lesson, let me tell you how to purchase my classes. So as you all know that I am conducting classes for grade 10 and 11. The theory class are available as well as the paper class, which you have joined now. So from next month, you are supposed to pay and continue the class. So therefore, let me tell you how to join through the website, right? So here you have something called courses, right? So when you first you have to log in, okay? Join for free, and then if you log in, you can get the courses, right? So once you click the courses, right? You will be getting all the courses that is conducted by WebTutor. So from that, choose my class. Here, science grade 11 and paper class. If you wanted to join both, you have to pay 1,500, right? So like that, you have the theory classes as well, right? If you wanted to join this class, just click that, right? So when you click it, here you can purchase the class, okay? If you click this, right? So you will get the, give me a minute.
Abdul Saadi can do class. Live.
Okay, so if you process this, you will get the bank details to which account you have to do the payment, right? So here you see, you will get the bank details, and if you submit the correct, word, the payment will be accepted, right? So then, before you join the classes, if you wanted to have a if you wanted to have a trial class, here are some trial class videos. You can watch them, and later, if you are satisfied, you can start joining. Okay. So this is how you have to purchase the class from the website, right? Did you all understand, children? Like many of you all were requesting to tell them on how to join, so that's why I told you all, right? If you all wanted to continue the class, you can make the payment through this method. Okay, right? Now let's get into the lesson. So as for the plan, let me share the lesson plan, right? Give me a minute. Let me share the lesson plan. Right, can you all see the screen? Can you all see the screen? Yes. Okay. So in the last before class, we did the structure of matter lesson, right? We have successfully completed the lesson and we did the past paper question as well. So did you all revise the lesson? Did you all revise the lesson, the one who joined for this class? Can you all leave a message in the chat? Did you all revise the lesson? Yes, great. Okay, so the last class we did the quantification of elements and compound, right? So did you all revise the last class lesson? Did you all revise this lesson and join the class? I have told you before you join a particular class, make sure to revise the previous lesson and come, right? So if you all have revised, that's a great thing. So today's class, we will be studying chemical bonds. For today's class, we will be doing chemical bonds. I will be giving a short revision on that, and then we will get into the question, right? So from next week, the entire chemistry plan is done. Therefore, on 30th, there is an open exam. That means I will send a question paper to the group. If you all wanted to check your level, in which level you all are, then you all can do that paper and resend me the answer sheet. With a particular time, if it is 2.5 hours, you're going to sit in a place, do the paper and send me the answer sheet. Right? Then I will be correcting that and submitting marks. So if you all wanted to do that, on 30th, I will be sending you a poster, like I will be sending all the details, the time and everything. So you all can do that on that particular time and resend me the answer sheet. Right? So, yeah. So for today, we will be doing the chemical bond lesson, which is 10th lesson of grade 10 syllabus. Right. So now let's get into the lesson. So if you all have any doubts while studying, leave a message to the co-host, right? So I can see your messages through that. Okay. Okay. Let's continue. Right. So chemical bonds. So today our class is all about chemical bonds. Right. So when you talk about chemical bonds, children, there are two types of chemical bonds. There are how many types of chemical bond? You all have to be interactive. Huh? If I ask a question, make sure you are replying. Even though if you are nervous to unmute and answer, just leave a message on the chat. Right? I will be seeing your messages. So that's where I can understand whether you are understood with the lesson or do you have any doubts. I can clarify on that. Okay? So when you talk about chemical bonds, there are two types of chemical bonds. How many types of chemical bonds, children? There are two types of chemical bonds. So the first type is the ionic bond. What is that bond? Ionic bond. So the first type of bond is ionic bond. And the second type of bond is covalent bond. What is that bond? Covalent bond. Children, this lesson is quite important when it is coming to the structure questions, right? At the time, this lesson will be interconnected with all the chemistry part. So when you get a chemistry question, you will get even a single question from this lesson. So therefore, make sure you are being very focused and studying this lesson, right? So first of all, let's talk about the covalent bond, right? First of all, let's talk about the covalent bond. Before we talk about the covalent bond, who is not familiar with the periodic table, can you please leave a message, children? The one who is not familiar with the periodic table, can you please leave a message on the chat to me? Saying that I don't know the periodic table. No worries, children. I will be helping you out. For that only I am asking. Is there anyone who is struggling with the periodic table? Is anyone like that? Leave a message to the chat. I'm waiting for your reply. So everyone clear with the periodic table? Like you all are fluent with that? Yes? Great. Then you all are great. Okay? Right. So take out the rough book. I have to. Guys, give me a minute. Sorry. Give me a minute, children.
1099. No, 1 minute and it's 1099.
Can you all mute yourself? Like it might be a disturbance for others. Make sure you're all the time muted unless you have a doubt. Okay? Unless you are having a doubt, make sure all the other time you're muted. Wait. Hamna Faris, can you please make me the host? Like due to my Zoom got disconnected, you have become the host right now. So can you make me the host, darling? Can you make the host? Right. Give me a minute. Okay, great. Thank you, dear. Okay. So talking about the periodic table, can you all please take out your notebook and write the periodic table with me? Shall we do it? Let's work together, okay? So what's the first element? Say it yourself. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. So are you all familiar with this order? Anyone who is struggling with this, make sure children, even though you all don't tell me, but I don't know, I'm not sure whether everybody is like fluent with this, but make sure, trust me, if you wanted to do a chemistry question, this is very necessary to know, right? Without this, you can't do a chemistry question, right? Don't think that you will, okay, I slightly remember the periodic table, therefore, okay, I can manage. No. Unless you are fluent with the periodic table, you can't do a chemistry question. It is very difficult. You will struggle a lot. Trust me. Right? So then you have how many groups in the periodic table? Send me in the chat. How many groups do you have in the periodic table, children? Come on, I want your replies. Okay, that's where you will learn. How many groups are there in the periodic table? Leave a message to the co-host, right? Leave a message to the co-host. Not to the co-host, leave a message to the host. Yeah. Everyone tell me how many groups are there in the periodic table. Very good. 8 groups. There are
Eight
how many
groups.
groups? There are 8 groups. And then you have 4 periods. And then you have how many periods, children? 4 periods. Very good. Very good. Okay. So you have 4 periods. So how does a valency flow? The first group has a valency of +1. Second group has a valency of +2. Third group has a valency of +3. Fourth group has a valency of +4 or -4. Fifth group has a valency of -3. Seventh group -2. Eighth group -1. Sorry, seventh group -1. And the last, eighth group has 0. So this is what you have to know thoroughly. You have to know the valency, you have to know the group number and the period number and all the 20 elements with their atomic number. When you get your paper, okay, maybe it is a term paper or the paper that you are trying for yourself, anything, take a rough paper, draw this periodic table. This will save your time, right? This is a tip. I told in the previous classes as well. So this is a tip. Make sure whenever you get a paper that you're trying a paper, okay, you write this on a rough paper. This will save your time, right? So this is the first thing that you have to know. And the polyatomic ion. And the polyatomic ion. Who doesn't know the polyatomic ion? I have told you there are 6 main polyatomic ions. Who doesn't know that? Like who are not there in the previous classes of mine, you all might not know that, right? So let me give that. Ammonium. Okay, before I get into the lesson, I just wanted to make sure that you all are familiar with all this. So then you will understand the theory part very clearly. If not, at between, like in middle, you have to struggle, right? Ammonium, NH4 plus. Hydroxide, OH minus. Nitride, NO3 minus. Sulfate, SO4 2 minus. Carbonate, CO3 2 minus. Phosphate, PO4 3 minus. So these are the 6 main polyatomic ions where you have to know. So trust me children, without these things, it is not easy to face a chemistry question. First make sure that you are thorough with this before you try a question. So let it today be the last day. If you don't know this, make sure today is the last day to memorize. Don't keep it for tomorrow, children. Anyways, you will not do it tomorrow. You will tell it on the other day. Okay, next day. And then the O level will come. And then at last, you are going to struggle. So don't keep a step like that. Now, I'm going to study this and complete it. If you all don't know this, take a screenshot and study it. Right? If you all don't know, if you all wanted to know this, take a screenshot and study this later. Okay. Let's get into the lesson. So make sure you're thorough with this. Okay. Let it today be the last day. You're going to sit and study and complete this. Because it is very important, children. Not as you think. It is important. When you try the question, you will understand why teacher told this is important. Right? So now let's get into what is ionic bond. Okay. Let's get into ionic bonds. Right. Children, now when you take the periodic table, let me draw it once again. I forgot and I erased it. Okay, so this is the periodic table, right? So for example, if I take the element sodium, what is the atomic number of sodium, children? What is the atomic number of sodium? I want everyone's reply. Come on, children, everyone has to reply. What is the atomic number of sodium? What is the atomic number of sodium? Everyone reply in the chat to the host. Okay, please don't reply to the co-host because I won't be seeing. Okay, now I have changed it to host. Eleven. So the periodic number, atomic number is 11. Children, leave a message to the host, not to the co-host, okay? So if you leave a message to the co-host, I will not be seeing your messages, right? Very good. So the atomic number of sodium is 11. So what is the electronic configuration? I hope that everyone is aware of what is electronic configuration. Can you all tell me what is electronic configuration of sodium? Leave a message to the host. Please don't reply to the co-host. I won't be seeing. Right? So what is the electronic configuration of sodium? 2, 8, 1. Children, if you all don't know how to find the electronic configuration and those stuff, this is related to unit 3 of grade 10. There is a free session happened on this lesson. If you all are struggling with these parts, make sure you watch the recording of that. Right? If I started to explain all the theory parts, I will not be able to complete the ionic bonds today. Right? So make sure if you want any lessons recording like the free class, leave a message to my number. I will send you the links. Right? Okay. So 2, 8, 1. Right. So now children, you have 8 groups, right? In the periodic table, you know you have 8 groups. Let me tell you as a story. Okay. Now, when you take neon, let's take the element neon, right? What is the atomic number of neon? What is the atomic number of neon? Leave a message. Send me in the chat. What is the atomic number of neon? 10, right? Then what is the electronic configuration of neon? What is the electronic configuration of neon? Very good. 2, 8. Okay, it is 2, 8. Now children, then tell me what is about argon. What is the atomic number of argon? Tell me what is the atomic number of argon? Very good. The atomic number of argon is 80. That means 2, 8, 8. Now children, when you compare all these three, what is the difference that you can identify? What is the difference that you can identify? When you take the valency shell, that means the outer shell, right? The outer shell. When you compare the outer shell, the elements in the group 8, these two are the elements from the group 8. They have a stable number. Remember children, if the last energy level has 8 electrons, that means their valency shell is stable. The element is stable. That's why you call this element as the noble gas or the stable element. You call that in that way since they have 8 electrons in the last energy level. Right? So the remaining 7 group elements, okay, they also wanted to have a stable electrons. They also wanted to have the 8 electrons in their last energy level. Therefore, some of the element has to remove electron or else they have to attract electron. So that is what you're going to learn in ionic bond, right? What is the idea? All the 7 group elements wanted to become group 8 element. They wanted to become something like group 8 element. Why? They have a complete energy level. They have a complete energy level. While the other group element will not have complete energy level. So therefore, they wanted to become something like group 8 element. Okay. So now when you talk about sodium, sodium has 1 electron in the last energy level. Sodium has 1 electron in the last energy level. Okay. So if it wanted to become 8, you have to attract 7 more electrons, right? Or else, if you remove this 1 electron, the last energy level has 8 electrons. They are stable. Either way, 2 ways are there. Either they should attract 7 more electrons to make this 1 as 8. Or else you have to remove this 1 electron. That therefore, they will have 8 electrons in the last energy level. Now tell me children, is it easy to attract 7 electrons or remove 1 electron? Is it the first option easy or the second option? Which one is easy? Send me in the chat. Send me in the chat. Which one is easy? Removing 1, attracting 7. Which one is easy? Removing 1. Removing 1 electron is easy, then you attract 7 electrons. Therefore, this sodium will remove this 1 electron. Now tell me, if a person removes negativity from his mind, will this person become a positive human or a negative human? Tell me, will this person become a positive human or a negative human? A positive human. Similarly, if an atom removes electron, they will become plus. Therefore, sodium atom will remove 1 electron and become Na plus. Did you all get the idea? Did you all get the idea? Great. So when an atom with a charge, okay, now sodium is an atom. If it has a charge, you call that as an ion. What is that, children? You call it as an ion. You don't call them as atom. If there is no charges, then it is an atom. If an atom with a charge, you call it as an ion. Now this is a positive ion, no? Therefore, you call it as a cation. If an atom with a positively charged ion, then you call that as a cation. Did you understand? Okay. So remember this idea for a moment. Right? Now let me take chlorine. Which is in the group 7. Right? What is the atomic number of chlorine? What is the atomic number of chlorine? Send your answers in the chat. Everyone's reply.
70.
Very good. The atomic number of chlorine is 70. Then what is the electronic configuration?
2,
What is
8,
the electronic configuration? Very good. 2, 8, 7. Right. Now, if you wanted to stabilize this last energy level, right? If you wanted to stabilize the last energy level, either you have to attract 1 electron or you have to remove this 7 electron. Now tell me children, is it easy to attract 1 electron or remove 7 electron? Is it the first option or the second option? Which one is easy?
First option.
First one. Now if they attract 1 electron, easily this 7 will become 8. Therefore, they will have a stable electronic configuration. At this point, chlorine is attracting negativity. That means similar idea, if a person attracts negativity to himself, then he will become a positive human or a negative human? Will he become a positive or a negative human?
Negative.
Negative human. Now replace this human with the chlorine. Chlorine attracts electron. Therefore, he will become Cl minus. Did you understand? Did you understand?
Yes, teacher.
Okay. Now, if an atom with a negative charge, you call it as an anion. What is that, children? What is it?
Anion.
Very good. If an atom with a positive charge, you call it as a cation. An atom with a negative charge, you call it as an anion. Now, children, let me tell you what is ionic bond. When a positive charge ion and a negative charge ion combines together, that you call it as an ionic bond. Okay, the attraction, electrostatic attraction. Okay, due to the electrostatic attraction between the positive charge ion and the negative charge ion, you call it as an ionic bond. Electrostatic attraction means the attraction between the positive and the negative ion, right? Attraction between the positive and the negative ion, you call it as the electrostatic attraction. Okay, now if the compound, okay, if a compound made up of sodium and chlorine, that is an ionic bond. If a bond that is made between sodium Na plus and Cl minus, that is an ionic bond, right? Now this sodium plus, right? When you take now sodium is 2, 8, 1, right? Sodium atom. When you take chlorine, 2, 8, 7, right? You are going to remove this one electron, therefore they will become plus. Cl will attract that one electron which was released by sodium. During the process of combining these two elements, okay, during the process by combining these two elements, this sodium will remove its one electron. Therefore, it will have a positive charge. That removed electron will be attracted by this chlorine. Therefore, it will have a negative charge, right? After this process, they will form NaCl. That is the common salt where we use at home. Sodium chloride. Did you understand, children? Did you understand?
Yes. Yes, teacher.
Everyone? Okay. So, did you understand what is an ionic bond? Due to the electrostatic attraction between the positive and the negative charge ion, you call that as the ionic bond. Okay. Now, to remember the characteristics and everything about ionic bond, remember the example sodium chloride. If you remember this example, easily you can answer all type of ionic bond question. Right, children? Remember the example sodium chloride. Did you all understand? Very clear?
Yes.
Any doubt? Any doubt? Leave a message. Uman, do you have any doubt?
Yes, yes.
Yes, dear. What's your doubt?
Please repeat it.
Do you want me to repeat it?
Yeah.
Okay. So look here. Now you're talking about the ionic bonds, right? Now, for example, I'm taking sodium. Sodium atomic number is 11. The electronic configuration is 2, 8, 1. Do you know how to find the electronic configuration? Yes? So this
Yes.
level, you have to distribute in each energy level, right? That KLMN, that energy level you have in the third lesson. So if you distribute it, you will get this value, right? So this is for sodium now. Now, as I told you, all the elements from the group 7, all these group 7 elements wanted to become group 8. Why? Now when you take neon, neon has a atomic number of 10, which is 2, 8. The electronic configuration is 2, 8. When you take argon, right? When you take argon, it is 18. 2, 8, 8. Right? 2, 8, 8. Right? What is the difference that you can observe from here? You see here the last energy level of the group 8 elements has 8 electrons. How many electrons? 8 electrons. Remember children, the last energy level, if they have 8 electrons, that means they have a stable energy level. Therefore, the group 8 elements will have a stable electronic configuration, while the other group elements will not have that. Therefore, they wanted to become someone like them. Therefore, if they wanted to become someone like them, either they should remove their electron or attract electron. Right? Either they have to remove their electron or attract electron. Right? Now, keeping on that idea, now the sodium atom has 1 in the last energy level. To make this 8, they should attract 7 more electrons, or simply they can remove this 1 electron. Therefore, this energy level will have 8. Then they will have a stable electronic configuration. Right? So, which is easy? Removing 1 electron or attracting 7 electrons? Which is easy?
Removing.
Removing 1 electron. Therefore, they will remove this 1 electron. Now, if a person, right, if a person removes negativity from himself, will this person become a positive human or a negative human, children? Will he become a positive or a negative?
human.
Positive human. Now, you remove all your negativities from your mind, you will become a positive human, where you will think all positively. So, therefore, similarly, this sodium will remove an electron and become a positive ion. Right? It will become a positive ion. So, that is a part of the lesson. Here it is removing. Here it is removing. Now, when you take chlorine, which has an atomic number of 17, the electronic configuration is 2, 8, 7. In this situation, either the last energy level should remove all 7 electrons, or they have to attract 1 electron. Which is easy? Removing all 7 or attracting 1?
Attracting.
Attracting 1. Therefore, this chlorine atom will attract 1 electron. If you are a person and you are attracting all the negativity, all negative thoughts, will you become a positive human or a negative human? Will you become a positive or a negative human? Children, will you become a positive or a negative human?
Negative human.
Negative human. Therefore, similarly, this chlorine is going to attract 1 electron. Therefore, it will become a negative ion. Right? Now, the bond. Right? The bond between the positively charged ion and the negatively charged ion, if they combine together, that you call an ionic bond. Right? Due to electrostatic attraction. What did I say for electrostatic attraction? A positively charged, the attraction between a positively charged ion and a negatively charged ion, you call it as electrostatic attraction. So due to that attraction, a bond is made. That bond, you call it as an ionic bond. Right? Therefore, the bond between sodium chloride is an ionic bond. Did you understand now? Any doubt?
No, you understood.
So next, right? Now let me teach you the characteristics, features. Right? For that, let me share the tube. So do you all have the tube with you all? Did you all take the printout of the tube?
Yes, madam.
Yeah. So it is for your goodness, because normally the soft copy all the time will not work. Right? All the time it will not work. So make sure, if I share something, if you are willing to join that particular class, make sure that have the tube in your hand. Right? Okay. Right. So this is the nude which I shared for you. Okay. So here I have attached a short note. Here I have attached a short note. Before we go into the what features, let me have a small idea. Right. So now the ionic bonds, right? The ionic bonds normally they are made between the group 1 or 2 elements, between the group 1 or 2 elements with group 6 or 7 elements, between group 6 or 7 elements. So what is the example that I told to remember for ionic bond? What is the example that I told?
NaCl.
Very good. I told sodium chloride, right? Now sodium. Sodium is an atom. Sodium is an element. So which group does it belong to? To which group does this belong to?
First and seventh.
It belongs to the group 1. Chlorine. To which group does it belong to?
Seven.
Group.
7. So the bond between the group 1 and 2 element, 1 and 7th group element, you call it as an ionic bond. Either 1 or 2 group elements with 6 or 7. Right? Another example. Potassium fluoride. Potassium belongs to group 1. Fluorine belongs to group 7. So the bond between these 2 elements, you call it as an ionic bond. So in an exam question, if you get set of answers, if it is an MCQ, identify an ionic compound. Okay, you have get a question similar to that. So easy way to identify is this. Check if the elements belong to one element belonging to 1 or 2 group element and the other one is belonging to 6 or 7 group element, then they are the ionic bond. Understood, children? Did you
Yes.
get the point? Okay. So the next one is the metals, right? You have the metals in the periodic table now. So metals and the non-metals. How do you find that, children? Right? In the periodic table, okay, in the periodic table, you draw a step-like thing from boron to silicon. Okay, from boron to silicon. Children, give me a minute. Let me refill my marker. Give me a minute. Right, okay. Okay, so you draw a step-like thing, right? From boron to silicon. So to the left-hand side, the elements, whatever you have from this side, those are metals. Those elements are metals. The right-hand side, from the step, those are non-metals. The elements which touch the step, those are metalloids. Those are metalloids, right? So according to that idea, so metals and the non-metals, okay, the metals and the non-metals with a polyatomic ion. Now I told you what are the 6 main polyatomic ion where you have to know, right? In your textbook there are around 12 to 15 maybe. So out of that there are 6 main polyatomic ion. Make sure to remember that. Not remember, memorize it. Okay. So the metals or the non-metals with a polyatomic ion, that is an ionic bond. If you take calcium carbonate, calcium is a metal. Carbonate is a polyatomic ion. The bond between them, you call it as an ionic bond. Did you understand?
No, miss.
No, teacher.
No, you all didn't? Okay. Now, children, you know what are the metals and the non-metals? No. Now, this is how children look. You have boron here, silicon here, right? So, you draw a step from boron to silicon. Something like this. Here you have boron, here you have carbon, and here you have silicon, right? So, left side to the step. That means from boron to here, right? Then you have lithium, beryllium, sodium, magnesium, aluminium, potassium, calcium. All those elements, these set of elements are metals. These set of elements are metals. Which touches the line, okay, the step line, those are metalloids. Okay, those are metalloids. Okay, right side, this side, okay, right side of this step, the remaining starting from what? Starting from nitrogen, phosphorus, all these elements are non-metals, right? All these elements are non-metals. Now, did you understand this part?
What is metalloid?
Metalloids are the elements which has the feature of metals as well as non-metals, right? It comes under lesson 3 of unit 10. Sorry, lesson 3 of grade 10. Structure of matter, there is a long part where you have to study like memorizing part about elements. So in that you have something called metalloids, right? Metals, metalloids, non-metal. Metal which has a metallic feature, non-metal which present in the form of liquid or gas. Metal means solid, right? Then metalloids, some of the element will have the metal feature and some of the element will have the non-metal feature. So those kind of elements you call it as metalloids, right? Now the combination between metals or non-metals, or non-metals with polyatomic ion, okay, with polyatomic ion, you call this combination, you call that bond as ionic bond. That is a second type. First type is group 1 or 2 element with group 6 or 7 element, right? That is one type where you can find, right? The next one is metals or non-metals with polyatomic ion, you call it as ionic bond. Example, calcium carbonate. Calcium is a metal. Calcium is a metal where it is left hand side to the step which we drew, right? Here is calcium, right? Calcium with carbonate. Carbonate is a polyatomic ion where I told the 6 main polyatomic ion. Out of that you have carbonate, right? So the bond, the connection made between these two is an ionic bond. Did you understand? Is it clear right now? Any doubt? Any doubt? Everyone leave a message. If you have any doubt, tell me.
No, teacher.
No. Okay. So the next one, the bond between polyatomic ion with another polyatomic ion, right? A polyatomic ion with another polyatomic ion. That bond you call it as an ionic bond, right? For example, if you have ammonium nitrate, right? Ammonium nitrate. Then I think I have given in the tube as ammonium phosphate. Check. Both are correct, but let me go with the tube itself, what I have provided. Okay, let it be ammonium nitrate below. So, ammonium is a polyatomic ion. Nitrate is also a polyatomic ion. The bond made between these two polyatomic ion is an ionic bond. Okay, is an ionic bond. Let me revise it once again. The first one, the ionic bond can be made between group 1 or 2 elements with group 6 or 7 elements, right? That's the first one. Second one, Metals or non-metals with a polyatomic ion. Metals or non-metals with a polyatomic ion. Third one, polyatomic ion with another polyatomic ion. That will form an ionic bond. Did you all understand, children? Any doubt? Any doubt? Any doubt? Right. Okay. So apart from that, so the bond, so if a compound is made out of ionic bond, you call it as an ionic compound, right? Now sodium chloride is made out of an ionic bond. The bond between sodium and chloride is the ionic bond. Therefore, this compound you call it as an ionic compound, right? This compound you call it as an ionic compound. Okay? Right. Apart from that, now let me, and then you have to remember this ionic compound will form a 3D structure. Okay, this will form a 3D structure which you call it as the ionic lattice. What is that, children? What is that? This ionic compound will form a 3D structure that you call it as the ionic lattice, right? I'll show you the picture of ionic lattice while we are doing the questions. Okay. For now, did you understand everything? Clear? Any doubt on ionic bonds? Any doubt? Clear. Great. If you have any doubt, leave a message or unmute and talk. Right? No problem. Anyways, you can do. Okay? Right. Okay. So we'll move to the next part. Right? Now let's talk about the features of ionic bond. Let me talk about the features of ionic bond. So if you have the printed quotes, take it to your hand, or else let me share this. Let me share the screen. Okay? Right. Okay. So you have 5 features of ionic bond. How many features, children? How many features do you have? How many features?
5.
Unmute, unmute. Very good. You have 5 features. I have given all 5 features, right? Let us discuss now. Okay. The first feature. What's the first feature? They are composed with positive. Okay, they are composed with positive and negative charge ions. Okay, remember the example. What is the example I told you all to remember? Sodium chloride. Okay, you know sodium has a positive charge. Chlorine has a negative charge. The bond made out of these two, between these two, you call it as the ionic bond. Okay, so you get the idea, right? If you remember sodium chloride, you can come up with the first feature. They have the feature of that. Don't scribble on the screen. Who is that? Right. So the next one. They have a high melting and boiling point. They have a high melting and boiling point. Right? Sodium. Now salt will not easily converted to a liquid state salt. Okay. You have the liquid state salt. If you wanted to convert to a gaseous state salt, it is not an easy process where you have to submit a huge amount of a temperature. At that point, they can convert it to liquid to gas. Right? That is a boiling point. Melting point is between solid to liquid. It is also not an easy method, right? So they have a high melting and boiling point. Remember sodium chloride, you can come up with all features of ionic compounds, right? Third one, they are mostly solid crystalline form at the room temperature. You have the salt, so it is in which form? In the room temperature. You find salt in which form, children? In which form? Solid. So they are in the solid form, crystal form. You can find salt in crystal form at the room temperature. So you come up with the third feature of ionic bonds, ionic compounds. Fourth, they conduct electricity in the molten state and in aqueous medium. So molten state means, children, when a substance which is in the solid state, where you wanted to convert that to liquid state by giving a huge temperature, that you call it as a molten state. That you call as what? Molten or fused. Both words you can use. Molten or fused state. Okay, what is molten? You don't have to know the definition behind that, but you have to know they can conduct electricity at molten state or in aqueous medium. What is aqueous medium? You have a substance with water, you call that as an aqueous medium. Salt plus water, where you have salt solution, they are in the aqueous medium. In that form, they can conduct electricity. Did you understand, children? Did you understand? Leave a message. Send me in the chat whether did you all understand or not.
Yes.
Great. Very good. Next one. Most of the ionic compounds are water soluble. You know, when you add salt to water, will they get dissolved or not? Will they dissolve or not?
Dissolve.
They will dissolve. Therefore, they are water soluble. Did you come across all 5 features of ionic compound when you have the example sodium chloride? Yes? So therefore, remember, if someone asks you about ionic compound, remember sodium chloride. You will be able to answer all questions. Molten means you have a substance which is in the solid state. Okay, you have a substance which is in the solid state. If you wanted to convert that solid state substance to a liquid state substance by giving a huge temperature, you have to supply a huge temperature to change their state, to change their medium from solid to liquid. So that point, if they at that point where you have to supply a huge temperature and you're converting from solid to liquid, that point you call it as a molten or the fused medium, fused state or the molten state. Both has the same meaning, right? Aqueous mean, now you have a substance, no? You have a substance, you have salt, sodium chloride. You add it with the water. You have water, you add water and sodium chloride. Then they will form an aqueous medium. They will form an aqueous medium. That you call it as an aqueous medium. A substance with water, you call it an aqueous medium. At that point, they will be able to conduct electricity. Ionic compounds will be able to conduct electricity in aqueous media or molten state. Did you all understand all 5 features of ionic bonds?
Yes, miss.
Okay. Now, memorize this. Memorize the 5. Quickly, I just give you all 3 minutes, not more than that. Memorize these 5. Everyone. Everyone has to do this. Huh? This is for your own good, children. Don't think that I am forcing you all to do or stressing you all. No. If you study it now, later you don't have to stress a lot when your exams are getting near. Remember one thing. Okay, remember one thing. This is the last time you're going to study ionic bonds in depth. Right? In depth, you're going to study ionic bonds. It is going to be today. Not tomorrow or not another day. Today, complete it. Complete it. Completely do it. Right? So make sure now you are studying this all 5 quickly. Once you all are done, raise your hand. Yes, dear, from next month, the paper class you have to pay and join. So for this month, I have given a chance that everyone can have opportunity to learn, right? So from next month, inshallah, you have to pay and join the class, right? Same time, yeah, same time. Yeah, the paper class is 750, okay? So if you are joining my theory class, grade 11 theory class and paper class, then in total you have to pay 1,500, right? If you are joining grade 10 class, grade 11 theory as well as the paper class, you have to pay only 2,500, right? Yeah, the grade 11 theory class have been started, like from the last week we have started. We are doing the 7th lesson, acid-base salts. So that lesson we have started. In 10, we had chemical compounds, chemical bonds. Okay, this lesson. I'm doing this lesson for the grade 10 theory. Okay, dear. Yes, I'll come here. Grade 10. What do you want me to do, dear? I'll come. Do you need any help? Right. Are you done, children? Are you done? Are you done? Yes. Great. Okay. So, Muhammad, can you tell me one feature of ionic compound? Tell me one feature of ionic compound. Unmute and speak.
They have a high melting and boiling point.
Very good. Hajara, can you tell me one feature of ionic compound? Unmute and speak, dear.
Water soluble.
Sorry, come again.
They are water soluble.
Very good. Who else completed study?
With positive and negative charged ions.
Very good, very good. Come on, the other one. Who is the other person? Abdullah, are you there? Can you tell me one feature of ionic compound? Abdullah, are you there, dear? Can you unmute and speak? Ahmed, can you tell me one feature of ionic compound? Make it fast, we can move to the next part. Ahmed, are you there? Umar, can you tell me one feature of ionic compound? Umar?
They are water soluble.
Yeah, it was already told by someone else. Can you tell me another one?
They conduct electricity in the molten state and in aqueous medium.
Very good, very good. Right. Abdullah or Ahmed, can you unmute and speak, dear? No reply? Can you unmute and tell? Ahmed or Abdullah, are you there in the class? Okay, we'll move to the next part. Are you clear with the ionic compounds now? Any doubt? Any doubt, children? No, great. Okay, so we'll move to the covalent bond and the Lewis structure. Right. So covalent bond is, children. Okay, now you are very clear with the ionic bonds, right? Now let's talk about the covalent bonds. So covalent bonds are the bonds made by sharing electron. What is that, children? Made by sharing electron. Now ionic bonds, you know that either they are giving an electron or attracting electron. That's where they get the plus or the minus charge. If they will get plus when they remove electron. If they attract electron, they will get a negative charge. So the bond made by them between, it is made out of either giving or taking electron, right? So covalent bond is done. Covalent bond is made up of sharing electron. They don't either give their electron or gain their electron. Gain another electron. They share between them. Right? What are they supposed to do? They share their electron. When you take carbon dioxide, right? You're going to take the example as what? Carbon dioxide, right? You take carbon. Okay, what is the electronic configuration of carbon, children? What is the electronic configuration of carbon?
2,4.
2,4. You have how many oxygens here?
2.
2. You have 2 oxygen. So what is the electronic configuration of oxygen?
2,6.
2,6. Very good. Give me a minute. So at last, remind me to show the ionic lattice and the covalent structures, right? Remind me to do that. Okay, before we get into this example, let me come up with a simple one to give you the brief idea. Let's take hydrogen gas. Let's take hydrogen gas, right? So how many hydrogen atoms are here, children?
2.
How many are there? 2. They have 2, right? So if you wanted to draw the electronic configuration, right? You have the nucleus at the center. You have the energy level, right? Let me mark the 1 electron of hydrogen. 1 hydrogen atom has 1, right? 2 hydrogen, no. Let me draw another circle, right? And their electron. Now all together, now let me forget about this electron. Consider this electron as well, right? Then totally how many electrons do this hydrogen atom has?
2.
Then you know that if they have 1 energy level, the first energy level, which is K, that should complete 2 electrons to have a stable energy level. To have a stable energy level, the first energy level should carry only 2. 2 is the maximum number of electrons that the first energy level can carry. You know that, right? Then this is the first energy level. They have 2 electrons. Is this atom completed? Are they stable?
Yes.
Now look at this. Okay, now look at this. Right? Are they stable? Look at this hydrogen atom. How many electrons do they have? It's not visible.
One
No, now earlier it was not visible.
electron.
Right? They have 2 electrons. If they have 2 electrons, they are stable. Now what has happened here, children? Has this, now let me mark a hydrogen 1 and hydrogen 2, right? Hydrogen A and hydrogen B. Okay, 2 atoms are there. Hydrogen A, hydrogen B, right? Now, has the hydrogen A atom given its electron to hydrogen B? Okay, have they given that atom? Have they given that electron?
No.
No. Have this hydrogen B atom given its electron to hydrogen A atom? No. What they have done is they are sharing the electron. You also take this electron. Let me also have this electron. Right? They are sharing the electrons. So those kind of bonds, you call it as the covalent bond. Did you understand? Did you understand?
Yes, madam.
Okay. So let me do another example. Right? Let me do another example. Let me take fluorine gas. F2. How many fluorine atoms are here in this molecule? How many
2.
fluorine atoms?
4.
They have 2.
2.
Let it be Fa, Fb. Right? So what is the electronic configuration of fluorine? What
2,
is the
7.
electronic configuration? Tell.
2,7.
2,8.
2, 7 will give you the
7.
electronic configuration of 1 chlorine atom. Let me draw that. You have the center nucleus. You have 2 electrons in the first energy level and you have 7 electrons. 2, 4, 6 and then 7. Right? This is Fa. Let me draw the Fb. Okay? Let me draw the Fb. Here you have the center, right? 2 electron, they have 7 electron. Two, 4, 6, 7, right? You have 7 electron here. This is Fb, right? Now, they should have how many electrons of this F1, Fa should have how many more electrons to become stable, children?
1 electron.
1 electron. Fb also should have how many electrons to be stable?
1 electron.
1 electron. Now, if this 1 electron and this 1 electron, if they share between each other, will it be stable?
Yes.
How do you prove that? Now you forget all these electrons. You have, remember, only you have this electron. Count this, the last energy level. You have 1, 2, 3, 4, 5, 6. This electron, you are going to take it from the Fb atom. 6, 7, 8. Do they have 8 in the last energy level?
Yes.
Then, if they have 8 electron, are they stable?
Yes.
Yes, they are stable, right? If they have 8 in the last energy level. Now, this is the second energy level, no dear. Second, third, fourth. If they have 8 electrons, they are stable. The first energy level, which is K, they only should have 2 maximum electrons. Okay, more than that, they can't carry. They can carry only 2 electrons. Therefore, the remaining energy level, if they have 8 electrons, they are stable. Then, Fa is stable, right? Fa is stable. Now, what are you going to do? You are going to take this 1 electron from here. Now, count this side. 1. This one is from Fa. 1, 2, 3, 4, 5, 6, 7, 8. Do you have 8 electrons? Do you have 8 electrons?
Yes.
Yeah. Then if they have 8 electrons, are they stable?
Yes.
Now let me draw the covalent structure. Okay, covalent structure of them. For the covalent structure, you are going to consider the last energy level. You are going to consider the last energy level. That means you are going to have this. Okay, your diagram should be neat enough to see. Okay, your diagram should be neat enough to see. Right, you are going to interconnect these two. Since this is the board, it is not that neat, but make sure when you are drawing on the paper, your diagrams are neat. Right? So here, how many electrons you had? 7. 4, 5, 6, 7. Right? Here, 7. 1, 2, 3, 4, 5, 6, 7. Right? Now here you can see when you close all this part, you will get 8. How? Let me mark these two on the other side. Right? Then if you have count this and see, you will get 8 electrons. Why? You are getting now see 1, 2, 3, 4, 5, 6, 7 and 1 from the FB. Okay? Totally you have 8 here. Similarly, when you do that here, you will get the same. Did you all understand? Did you all understand, children?
Yes.
Yes, ma'am.
Alright. Now let me do for the carbon dioxide. Let's do for the carbon dioxide. Okay? Similar idea. Carbon. What is the electronic configuration of carbon? What is the electronic configuration of
2, 4.
carbon?
2,
2,
4.
4. Oxygen?
2, 6. 2,
2,
6.
6. Okay, 2, 6. Right? How many oxygen atoms do you have? 2 and 1 carbon atom. Therefore, you bring the carbon atom at the center and you bring the oxygen atom on the both the side. Right? Now what you do? To draw the covalent structure, you need the last energy level, electrons. Then you are going to draw one circle. Okay, make sure they are interconnecting. Make sure they are interconnecting like this. You are going to draw the 4 electrons of carbon. Right? Let it be. Let's take as cross and dots. Right? For your identification. Right? Since I wanted to teach, let me take it as a cross and dot. Let me take the bonds of carbon as, the electrons of carbon as cross. Right? Let me take the electrons of carbon as cross. Did you understand this part? Like it is not that neat. Okay, but make sure you all are drawing it neatly. Okay? Right? Understood? Wait, let me draw it a little more neat. Okay? Right. I think it is. I think the camera is moved. Okay? See, now it is little better. Okay? Now you are going to draw the carbon electron in the cross. Okay? Let me draw the carbon electron and the cross. And the oxygen in dots. Right? In oxygen dots. Let me mark 2 electrons here. 2 electrons here. 2 electrons here. Did you understand how did I draw? Did you understand? Anyone has a doubt here? Anyone has a doubt here? Okay. Now, similarly, you're going to draw the 6 atoms here as well. Right? Okay. Now, check. You're going to move this, including the cross. Count. Do you have 8? Will it be coming 8? Check and tell me. You have 2, 4, 6, 8. 8. Are they complete then? Is this oxygen atom complete? Yes or no?
Yes. Yes.
Yes.
Yes, right? Then you come to this oxygen atom. You forget this, right? Now count and tell me, do they make 8? Do they come up with 8?
Yes.
2, 4, 6, 8. Yes. Are they stable then? Yes. Right? Now forget about both the side, including the cross and dots. Count and tell me, does carbon has 8 electrons?
Yes, it has.
Yes? Yeah. Okay, they have 8 electrons. Now did you see, children? Did this carbon atom, that means the cross, did they give this 2 electrons to this oxygen? Like completely you itself take it, I don't want. Did they say that? No. Similarly, this oxygen atoms, did they told that, okay, I'm going to give you 4 electrons? Did they tell that? No. Let me also have that 4 electrons and let you also have that 4 electrons. Did you understand that they are sharing their electron? They are not either giving or attracting. They are not removing their electron or they are not attracting their electron. They are sharing their electron. Did you understand? Did you understand that point?
Yes, ma'am.
Okay. So this is covalent bonds. Okay. Their bonds are made by sharing electrons. So this is the covalent structure. What is this, children? Covalent structure. If they ask you for the covalent structure, you have to draw the last energy level and you have to indicate the electrons. Make sure you're indicating where they can make up things. Now, if I put these 2 electrons here, can I show them that they are involving in this? No. Therefore, what did I do? I keep it here. Therefore, to show that, okay, they are also involving in this. So, make sure you're drawing something like that. Okay? Clear? Any doubts? Any doubts? Let me know in the chat. Anyone has a doubt, leave me a message. I'll explain it. Okay. Clear. Great. Anyone else having a doubt? Okay. So
Hello.
we'll go to the next part. Right? We'll move to the
Hello.
next part. Okay. So now let me draw the Lewis structure for carbon dioxide itself. Since I have drawn this, let me continue with this one itself. Right? So let me draw the Lewis dot and cross diagram. So in the Lewis dot and cross diagram, you are not going to draw the energy level. Without the energy level, you indicate the dot and the cross. That is Lewis dot and cross diagram. Look, children, this is important. They can ask you to draw the Lewis structures. Okay, Lewis dot and cross or Lewis dot diagram or Lewis structure. Now we are going to draw Lewis dot and cross diagram. Right? Let me take the carbon cross and oxygen dots. Right? You are going to draw O, C for carbon and O for oxygen. You are going to have 2 electrons here. Okay? 2 electrons, 2 electrons. Carbon crosses. Here, you are going to make the between. Right? 1 dot, 1 cross. 1 dot, 1 cross. So that shows that you are sharing the electrons. That shows it is sharing the electrons. Similarly, you draw it on the other side. Cross, cross. Dot in between. You have 2 dots, 2 dots. Okay? Now when you look at this, look, do you have 8? This is more easier to find it out. Do you have 8? Now, forget about these 2. Do you have 8? Yes?
Yes.
Now come at this side. Do you have 8? Yes?
Yes.
Are these 3 atoms are stable? Yes. If they have 8 in the last energy level, 8 electrons in the last energy level, they are stable. Understood? how to draw the dot and cross diagram, Lewis dot and cross diagram. Any doubt? Any doubt? Yes or no? Do you have any doubt? Leave a message in the chat. Therefore, I can look for it. Oh. Oh, no doubts. Right. So let me draw the Lewis dot diagram. What are you going to do here? You're going to represent all the electrons in dots. You convert this to a dot. You convert this to a dot. Dot. Here dot. So this is the Lewis dot diagram. Understood? You represent everything in a dot diagram. Right? Here now you draw it in this way. Since like this, 4. Okay, same thing what I did. Okay, 4. In this way. Did you understand? Any doubt? Come on children, unmute and speak. That's where I can understand whether did you all understand or not. Clear? Any doubt? I am waiting for your replies. Can you all reply? Okay. So, the next one is the Lewis structure. Next one is the Lewis structure. Now, at a point where a cross and a dot you have, right? At a point where do you have a cross and a dot, there you draw a line. Now here initially before I draw this, it was something like this in the dot and cross diagram. Here was a cross, dot, cross, dot, dot, cross, dot, cross, dot. It was something like this now. Instead of this, what you do? You put 2 lines. You put 2 dash. That is Lewis structure. That is Lewis structure. When they are paired, cross and a dot is paired, you mention in a dash. That is the Lewis structure. Did you all understand, children? Did you all understand? Any doubts? Any doubt? Yes or no?
Madam, can you explain this dot and cross method?
Dot and cross, yeah. Now dear, initially what did we do? We gave cross for the carbon electrons and dots for the oxygen electrons. So carbon has 4 electrons in the last energy level. In the covalent bond, you are going to consider only the last energy levels. Right? That means they have 4. What you do? You draw 4 cross. You draw 4 cross where you can give to 2 other atoms as well. Right? Where you can balance it between 2 other atoms as well. 2 oxygen atoms. Right? Then oxygen has how many electrons in the last energy level? They have 6. You draw in between them. You draw in between them. So this is the dot and cross diagram. Same thing now. This is a pair. No, this is a pair. This is a pair. Where you have a dot and a cross, that is a pair. Instead of doing this, if they ask you the Lewis structure, how many pairs do they make? How many pairs do they make? How many pairs? Unmute and answer, everyone. I want your replies. You have 1
2
pair.
pairs.
They make 4 pairs. You do that. You put 4 dashes. That is the Lewis structure. The remaining electrons, these are, you call as the lone pairs. You call as the lone pairs or the lone electrons, right? So how many lone electrons are there in the carbon dioxide atom? If they ask you a question like that, how many lone pair of electrons are there? You have 4 pair of lone electrons. There are 4 pairs of lone electrons in the carbon dioxide bond. Did you understand? Any doubt? Any doubt?
No, madam.
Right. So now let me share the tute. Now similarly, can you please memorize the features of covalent bonds? Let me share that.
Yes.
So make sure children you all are studying now itself and finish it off. So then you don't have to struggle at the end. That's what I'm telling you. Okay, now itself finish it. Then you can be free. Right? So look here, before memorizing that, covalent bonds formed by sharing electron. Here, what is that? Due to electrostatic attraction between positive charge ion and the negative charge. They are giving and taking policy. Right? Here, sharing policy. If you want, write it and keep. For simple terms, you can use them. But don't write that in the exam paper. Okay? For your knowledge. To easy understanding purpose, you can do as that as well. So bond formed with any combination. Now, their bond can be formed by any combination. That can be a polyatomic ion and polyatomic ion or whatever. They don't have rules like the ionic bonds. Like group 1 or 2 element which should make bonds with 6 or 7. Nothing like that. Even the group 4 and 5 also can make a covalent bond. Right? Something like that. Okay? So they don't have any rules to form bonds. Okay? Some compounds form a covalent structure, right? That covalent structure you call it as an atomic lattice. You will have it in the textbook, the pictures, right? If I can at the end, if you will remind me, I'll show it. Okay, if not, just go through the textbook. Ionic bonds will form an ionic lattice and the covalent bond will form atomic lattice. Okay, so the atomic lattice are diamond and graphite. I'm sorry. So the atomic lattice are what? Diamond and graphite. So just for the remembrance, you have to remember. You don't have a deep idea on what is atomic lattice and everything. Just remember some covalent compounds will form a atomic lattice. So example for that is diamond and graphite. Okay? Okay, any doubts so far? Clear with every part? Clear? Yes or no? Right. Okay. Now look at this. Look at the features. Let's talk about the features here. Right. So the covalent compounds mostly exist as a molecule. Now when you take the example as carbon dioxide, they exist in nature as what? As a molecule. What is a molecule? When you have similar or dissimilar atoms together, you call it as a molecule. Okay, similar or dissimilar atoms together, you call it as a molecule. Okay, that is the definition for molecule. I told it in the last class as well. Right. Okay. That's the first feature. Second one, they have a low melting and a boiling point. Now remember children, the opposite of ionic bond is covalent bond. Opposite of ionic bond is covalent bond. Here they have a high melting and a boiling point, while the covalent bond has a low melting and a boiling point. Did you get that point? Did you understand?
Yes.
Right. Here, mostly they are found in the liquid and the gaseous state. Here, ionic bonds are solid crystalline at the room temperature, while the covalent bonds are liquid or gaseous state. They are found in liquid or gaseous state. Understood? Right. The fourth one. The aqueous solution of the covalent bond do not conduct electricity. Here the aqueous medium, okay, the aqueous solution of ionic compound will conduct electricity, while covalent bonds aqueous medium will not conduct electricity. Did you understand? Yes? Okay. So some of the covalent bonds are water water soluble. Here, most of the ionic bonds are water soluble. Here, some of the covalent bonds. So let me give you 3 minutes, children. Quickly memorize this 5. Quickly memorize it. It is for your own good. Study now itself. Right? The opposite of ionic bond is covalent bond. Finish it now itself, everyone. Once you all are done, let me know. At the meantime, if you have any doubt, leave a message. If you have any doubt, right, leave a message. So once we is done memorizing this, you all can move to the questions, right? So I have planned to do an extra class on discussing all the questions like the structure and the essay from the chemistry lesson. That means the structure of matter, quantification of element, chemical bonds and changes of matter. Like the next week, not the next week, the week after that. Okay. So between that, I will be doing a free session where I will be discussing all the chemistry based, grade 10 chemistry based structure and essay questions. Right? Here I am doing the MCQ because most of the lessons are interconnected now. So if I do one lesson, I can't do the structure or the essay question because you all won't have the complete knowledge. So I just wanted to make sure that you all are having the complete knowledge while doing that session. So once the next week we will be completing the entire chemistry of grade 10. Then inshallah we will be doing some questions relevant to grade 10. Some questions relevant to grade 10 chemistry. Okay. I'll let you know the date and the time. Are you done memorizing? If you all are done memorizing, raise your hand so then I can know. Very good. Okay, Hajra, can you tell me one feature of covalent compound? Can you tell me
They
one
do not
feature?
conduct electricity in aqueous medium, aqueous state.
Very good. Muhammad, can you tell me one feature of covalent bonds?
They have a low melting and boiling point.
Very good. So who else done? Once. Umar, are you done? So if you are done, can you unmute and tell me? Okay, someone unmute and tell. Another one.
They exist as molecules.
Some are water soluble.
Sorry dear, come again.
Some are water soluble.
Yes, very good. So make sure you remember this forever. Once in a while, just go through this. Okay, this is the simplest form that I have given. So make sure you are revising those again and again. Right? Don't make it like you forget it now itself. Just keep on revising till your exam. Right. Now can you all please do the questions? Do the first 3 questions. Right? Can I do the first 3 questions? 2016 and 19. In 19 you have 2 questions. So 9:30 we will be ending the class. So make sure to do it fast. We can discuss it quickly. Once you are done, raise your hand, children. So children, if you all want any class recording like the previous classes, if you all have missed, leave a message to my WhatsApp number. I will send you the link and everything, whatever you need, right? The tunes, anything, the lessons tune. If you want anything, just leave a message to my WhatsApp number. I will send it. Okay, done with the first 3 questions. And remember children, most of the covalent bonds are homoatomic molecules. Okay, they are homoatomic molecules. That means same atom combines together. Hydrogen atom, fluorine atom, oxygen gas. So all those are, now F2 is something like this. Okay, F2 is this, where 2 fluorine atom combines together. Okay, similarly hydrogen gas is also same. Oxygen is also the same. So these kind of molecules, you call it as the homoatomic molecule. Homoatomic molecule, right? So these molecule, you call it as a homoatomic molecule, right? So these are generally covalent bond. They are generally covalent bond. So remember that. So if you all are done, raise your hand. If you all are done with the first 3 questions. Very good. Come on children, make it fast. 2 girls have done. How about the remaining children? Can you please do it? So we can discuss. Ahmed, Muhammad, Umar, can you please do it soon? So that we can discuss. We have little more time to end the session. Like almost 22 minutes we have. So we have discussed. So if anyone didn't get this tune from the group, leave a message to my WhatsApp number. Who doesn't have my number, can you drop me a message? Who doesn't have my number? Leave a message. Drop a message in the chat. Okay, let me write it on the board. My number. Okay, send a message to this number. I will send the recordings, the needed recordings or the instruction to join the class. Anything, right? Any help will be replied through this number. So I am Miss Fatima. So if you have any doubts related to science, leave a message. I'll help you out. Without any hesitation, leave a message. I'll help you out. Right. We'll discuss. I think that's enough of time. Right. The number of lone pairs electrons around oxygen atom in water. What is that answer, children?
2.
Yes. You have 2 pairs. Now they are asking about the pairs, maybe children. If not, you can tell it as 4. Okay, you will have 4 in the remaining where you don't make that bonds. Okay, so that will be in remaining. But here they are asking for the lone pairs of electrons. That is 2. Okay, lone pairs of electrons, that is 2. Did you all get the answer? Leave a message. Did you all get the answer? Or
Yes, madam.
very good, very good. If you all get it, good job. Right? So the next question. Which of the following molecule made out of two covalent bonds? What is that?
Chlorine.
Cl2.
Made out of two covalent bonds. How about others answer? What did you say?
Cl2.
You also got two? Yes. So the answer is yeah. Second. Two is the answer. Okay. So the next question. Consider the following substance. A. Solid sodium chloride crystals. B. Molten sodium chloride. Aqueous sodium chloride solution. Which of the above can conduct electricity? Which of them? What is the answer?
Molten.
O2.
That is B and C. Molten and aqueous. Solid crystals will not conduct. Molten and aqueous. That is B and C. Therefore, third one is the answer. Understood? Yes?
Yes, madam.
Okay. So can you all do the third this question also 2020 question as well?
Done, madam.
Done. Okay, what is the answer?
O2.
O2. Which of the following is the molecule with the highest number of covalent bonds, right? So how many bonds do they have? Isn't it this? The third one? Isn't it that? So how about others answer?
Same answer.
What others answer? So I think it should be you have nitrogen here. Yeah, it is a third one, dear. Right? You have nitrogen and you have 3 hydrogen bonds. So apart from that, this will have 3 bonds. Right? Here 2 and here 2. This has the highest. Right? Second one. Oh, give me a minute. Right, do the remaining questions as well. Complete it.
Excuse me, madam.
Yes, dear.
Can you explain me that question, that 2020 MCQ question?
Yeah. Now look. Hydrogen. Sorry, not hydrogen. Oxygen, right? While they are making an oxygen covalent bond, there are going to be 2 oxygen atoms, no children. There are going to be 2 oxygen atoms. So these 2 will make up a bond. Right? These 2 will make up a bond. That means 2 have been involved. Right? Here is also the same. 2 nitrogen atoms. Here nitrogen 1, 3 hydrogen. Nitrogen 1, 3 hydrogen. So all together they will make up 4. Okay, there will be 4 covalent bonds. Here, Muhammad, give me a minute. I'll tell you the answer. Right? Here, carbon dioxide 1 carbon, 2 oxygen. Then 3. Which has the highest number of covalent bonds? Third one. So that is the third one. Okay. So which one, Muhammad, you wanted to know? Question is 2019, no? That one. 2019. What did you all get for the 2019 answer? I haven't marked it. So that should be the fourth one, I guess. Is it the fourth one? Made out of two covalent bonds, two different. You have hydrogen, there can be, I think there is an error in this question. Like all the, like except for the chlorine, the remaining everything has two covalent bonds, right? What did you get for this? 2019 children, what did you get the answer? Anyone got any answers? Do I have made a mistake in the question? Which of the following? Yeah, I think there is a mistake in that question. Can I check with the past paper? Give me a minute, I'll check. I think there is a mistake in the question paper itself. Let me check. Give me a minute. Did you get the answer? I couldn't find my past paper book. Did you get the answer, children? Did you go through the past paper? I think I have made a mistake in the question. That's so? Is that so? Yes? Okay, I'll check with that question. Okay, I'll check with that question. Right, keep it pending. I'll let you know in the group. Okay, maybe I have made the wrong one. Right, so can you all do this? 2023 question. Can you all do this, children? So what is the answer for this question? Which of the following statement is not true about the ionic compound? They conduct electricity in the solid state, that is state. Okay. Do they conduct electricity in the solid state? Do they conduct electricity in the solid state? Can I get your answers, please?
No.
No. So that is the answer. So others will give all dissolve well in the water. Right? Ionic bonds mostly they dissolve well in the water. Right? Boiling and the melting point take high values. Yes. They do not conduct electricity in the fused state. They do conduct electricity. Therefore, the wrong statement is the first one. So did you all understand? So I do have a doubt in the 2019 question. Let me clarify with that because most of the past paper marking schemes are wrong actually. Because I do have a doubt. Maybe the question is wrong. What they have asked because two made out of two covalent bonds is can be. Maybe if they ask which of the following is not made out of two coal, more than that means it can be this methane. It can be this. But made out of two covalent bonds, they can either be chlorine or they can be water. Okay, they can be chlorine or water. So that is the confusion I have. Is it the first or the fourth? So let me clarify with you. I'll drop a message on the group which is the answer. Okay. I'll just check with the past papers and the past paper marking scheme and then let you all know. Right? So do you all have any doubts apart from that? Any doubts to be clarified?
No, madam.
Okay. So then that's all for today. So next week we will be doing the changes in matter, which is one of the most important lesson, right? So make sure to join the class, right? If you all wanted to be benefited, just make sure to join the class same day, same time. Okay? So hope you all understood the lesson and it was helpful. So if you all have any doubts, if you all didn't understand any parts of the lesson, just leave a message to my WhatsApp number. I'll reply to your message. Okay? You're welcome, dear. So that's all you all can see. Yes, dear. Yes. Did someone speak?
Madam, what is fused state, madam? Is that late?
Sorry, can you
Madam,
repeat
it
it?
is fused wires, right?
Come again.
Madam, state,
You're lagging, dear. Can you send a message? Leave a message on the chat. You're lagging. Fused state and the molten state is the same, dear. Right? Fused state is where the substance, where you are converting from a solid state medium to a liquid state medium. To convert that, you are supplying a high amount of temperature. So at that situation, you call it as the fused or the molten state. So during that process, during that time, you can conduct electricity out of an ionic bond. Ionic compound, you can conduct electricity. Did you understand? Did you understand?
yes, madam. Madam, then fourth one also wrong, no, madam.
Which one, dear? Here they say they
Fourth
do.
one, madam. Madam, what is the answer for the 2020?
Yeah. I think there's a mistake in this question. I think the past paper itself have made a mistake. Because I took it from the past papers. Like then that is itself wrong means I think the question which the government has issued is wrong. Let me check with the past paper, but just now I also noticed that they asked me for the not true statement, right? So there can be the first one or the third one as well, right? Sorry, the fourth one, no? So let me check with the past paper. Like if you get the correct one, just leave a message to my number, okay? Okay, dear?
Okay, madam. Thank you, madam.
Welcome.